G'day, science lovers. Fancy a trip at light speed? Have you ever been stuck in traffic, crawling along at a snail's pace, and wished you could just hit a button and zip off to your destination in the blink of an eye? Imagine a trip so fast that you could circle the entire planet 7.5 times in a single second. Sounds like something straight out of a sci-fi movie, doesn't it? Well, that's the kind of speed we're talking about when we chat about the speed of light. It's the universe's ultimate speedster, the absolute gold medalist in the cosmic Olympics of velocity. But what if we, as clever humans, could actually build a machine that could reach this incredible speed? What would it feel like? What would happen to us and our spaceship? Let's strap ourselves in and get ready for a mind-bending journey into the physics of the impossible. The dream of traveling among the stars has been with us for as long as we've looked up at the night sky. From our ancient ancestors telling stories about the constellations, to our modern-day rocket scientists plotting courses to Mars and beyond, the desire to explore the great unknown is part of what makes us human. The biggest hurdle, the great big wall standing between us and the rest of the galaxy, has always been distance. Right then, let's get our heads around this number. The speed of light, often called c by the science boffins, is roughly 300,000 kilometers per second. That's not per hour, mind you, that's per second. It's a number so big that our brains have a tough time really grasping it. Think about it this way. If you were to switch on a torch, the light from that torch would be on the moon in just over a second. A commercial jet airliner cruises at about 900 kilometers per hour, which feels pretty fast when you're sipping a tiny tomato juice at 30,000 feet. But light is about 1,000,000 times faster than that. It is, to put it mildly, ridiculously, preposterously quick. It's the universe's express lane, and everything else is just crawling along in the slow lane. To give you another bit of perspective, let's talk about a trip around our big blue and green marble, Earth. Now, for centuries, people thought speed was simple. If you're on a train moving at 100 kilometers per hour, and you throw a ball forward at 20 kilometers per hour, someone on the ground would see the ball moving at 120 kilometers per hour. Simple addition. It just makes sense, right? This was the world of Isaac Newton, a world of straightforward, predictable motion. But then, in the early 20th century, a young patent clerk with wild hair and an even wilder imagination came along and turned everything upside down. His name was Albert Einstein, and he was about to introduce a very big but into the conversation about speed. He completely changed the game with his theory of special relativity. So, why is this speed of light the ultimate cosmic speed limit? Why can't we just build a more powerful rocket and push past it? The answer lies in one of the most famous equations in all of science, E equals mc squared. Even if you're not a science nut, you've probably seen it on a t-shirt or in a movie. It's Einstein's masterpiece, and it reveals a deep connection between energy and mass. What it's really telling us is that mass is just a super concentrated form of energy. They are two sides of the same coin. You can convert mass into a huge amount of energy, which is how nuclear power and bombs work. And you can also convert a huge amount of energy into mass. Now think about what it takes to make something go faster. Let's say, for the sake of a good story, we could somehow build a ship that gets incredibly close to light speed, say 99.999% of seat. What would happen to the ship itself? Well, according to Einstein's special relativity, another truly weird thing occurs: length contraction. From the perspective of someone watching you whiz by from Earth, your magnificent gleaming starship would appear to get shorter in the direction it's traveling. It wouldn't get skinnier or smaller in all dimensions, just squashed along its length. Right, so your mass is going through the roof and your spaceship is getting squashed. What else could possibly go wrong? Well, get ready for the biggest head-scratcher of them all. Time itself starts to slow down. This isn't just a feeling of time dragging on, like during a boring lecture. This is a real, measurable physical phenomenon called time dilation. For you, the intrepid space traveler moving at near light speed, time would pass much, much more slowly than it would for everyone you left behind on Earth. Your watch would tick slower, your heart would beat slower, and you would age slower, all from the perspective of an outside observer. Let's imagine a fun little trip to our nearest star system, Alpha Centauri, about 4.3 light-years away. We touched on this before, but it's worth digging into a bit deeper, because it's the absolute showstopper. The reason you can't get to light speed is all about mass and energy. Let's think about it with a good old Aussie analogy. Imagine you're trying to push a wheelbarrow full of bricks up a hill. At first it's tough, but you can get it moving. Now imagine that for every step you take up the hill, a mischievous gremlin adds another brick to the wheelbarrow. The faster you try to go, the more bricks the gremlin adds, and the heavier the wheelbarrow gets. Soon it's so heavy you can't push it any further, no matter how hard you try. That's a pretty good picture of what happens when you approach the speed of light. The energy you pour into your spaceship to accelerate it acts like that gremlin. So after all this mind-bending physics, what have we learned? The big idea is that the speed of light is more than just a number. It's the very foundation upon which our reality is built. It's the constant that governs the relationship between space, time, mass, and energy. The universe we live in has these rules hard-coded into its operating system, and they lead to some truly strange but wonderful consequences. The fact that we, as a species of clever apes on a small rocky planet, have been able to figure this out is nothing short of incredible. Einstein's theories have given us a peek under the bonnet of the cosmos. Reaching the speed of light is, for anything with mass, impossible. But the dream of interstellar travel isn't dead. While we can't hit CE, the laws of physics don't forbid us from getting very, very close to it. How amazing is that?